Hi. Now I would like to introduce you the terms that we use from time to time. These terms are the open circuit and short circuit and deactivation of a circuit. These are the terms that we use quite often. Uh, on an example that will be more clear for you. So if you look at this example now, we've got a one independent voltage source here. Independent voltage source, let me write that in black. This is independent voltage source. What does this mean? Short circuit of an independent voltage source. Short circuit of an independent voltage source. So that means make this independent voltage source voltage equal to zero. That means this mathematically. What does this mean is to make that voltage equal to zero. How are you going to make it zero in practice? I'll show it the difference that you're going to do. You're going to put a wire between the terminals of this element, removing this element. Take this off and put a wire there. So that means you made it short circuit. Be careful if you are doing a short circuit on the wall plug at your house. That is a bit dangerous. Why is that? Because there is a voltage there that in your house it's not 8 volts, of course it is 220 volts, a bit high voltage. So when you connect a wire without removing it, that means you are forcing to 220 volts to make it 0 volts. That means there's going to be on that wire, this exists plus that wire exists, means there's going to be a high current passing through that. So if it is you as well doing the connection, so that means if you put two terminals of your independent voltage source, that means plug on the wall. If you touch your fingers on it, so that means you become that resistance, that short circuit element. So that means that current is going to pass through your body. That's very dangerous. Don't do it. Do not short circuit independent sources. That is the conclusion that you can get out of this explanation. So if we do the open circuit independent voltage source, open circuit of an independent voltage source means make the current equal to zero. So you're going to make this current, this element current zero. How are you going to make it? You could do it in practice like this. So you're going to cut one of the connection or one of the terminal of this element. Then that means there's no current passing through. That means that current equal to zero. So you might consider these two together as a switch. If there is a switch here, assume that a switch here, that means on-off button. So when it is on, that means you connected these two lines, you made it zero, these 2.0, make it short circuit. If you open it, that means you made it open circuit, that means you made this What does this mean? There is no current drive to the circuit. So that means no energy passed through, because the energy of this independent voltage source now is equal to 0. Why is that? Because the power is a multiplication, the current and the voltage here gives you 0 since the current is 0. So integral of 0 gives you 0. That's why on-off switch means applying energy or cutting the energy. Another interpretation of that. Another terminology that we use is deactivation. Deactivation of an independent source. Let me write it in different color. Deactivation of an independent source. So it has some meaning. If it is independent voltage source, then Vs is going to be equal to 0. That means you're going to make it short circuit when you're deactivating it. When you are deactivating of an independent current source, that means the current of this independent current source is going to be equal to 0. That means open circuit, isn't it? So you're going to make independent current source open circuit, independent voltage source as a short circuit. Another example that I would like to show you related with this terminology is when you short circuit an element, it affects the other elements, whether they become open circuit or the short circuit. So if we use now this one, so this is an example of making the terminals VAB equal to 0. That means VAB equal to 0. That means short circuit of the terminals A and B. A and B. So you make it VAB equal to 0. When you make that VAB equal to 0, so that means you're going to make a short circuit here. This is that line. At the same time, this resistor voltage becomes 0. So if you write the resistor definition relation here, V equal R times A. So when you make this A and B terminals voltage 0, that means short circuit, that means you are short circuiting this resistor as well. Means this voltage is also equal to 0. And R, we know it is different from 0. If R is different from 0, then I becomes 0. So this is a different case. When you are talking about a resistor, both the voltage and current become 0. That means resistor becomes open circuit and the short circuit at the same time. It is not true for the other elements. For this element, for example, when you short circuit this element, there is a current passing through. That's short circuit current. When you open one of the wire here, the current is equal to 0, but there could be a voltage. So that means that when the voltage is 0, current is not 0. In here, when the current is 0, voltage is not 0. But if you are talking about a resistor, both of the current and voltages become 0. That means resistor becomes at the same time open circuit and the short circuit. So what does this mean? What we are going to do to represent this in practice, we are going to make that resistor open circuit. We are going to remove it. Why is that? Because if you don't remove it, there could be a current passing through. So therefore, we consider it as open circuit and remove this element. On the other hand, since we've got that A and B terminals short circuited here, that means I realize that's 0 as well. Conclusion is that when it is a resistor, if the resistor is open short circuit, that means you're going to remove that resistor from the circuit. What about the other elements? But this short circuit affected the resistor here. At the same time, it affects when you make this equal to 0. So we are talking about this, this area here. You make this 0. On the other hand, there is a dependent voltage source here, voltage controlled voltage source, of which voltage is controlled by this V. We made already that V equal to 0. Then that means this element becomes 0 as well. This element voltage becomes 0. When V is 0, this element voltage is 0. That means voltage is 0. That's short circuit. That's this short circuit. So when I made a short circuit, the terminals A and B, this resistor affected. At the same time, this dependent source is also affected. So it might affect more than one element at the same time. So we've got to keep in mind those cases. Okay, that's the end of this video then.